AQA Level 2 Sample Paper, question 12c from the calculator section. Okay, so this is still referring back to the quizzes that Stefan and Eve are doing, but actually when we look at 12c, we don't need this information at all. Let's just read the question. In the next quiz, there are 2 multiple choice questions. Each question has 3 options to choose from. Stefan does not know the answers to the questions. He chooses at random an answer to each question. What is the probability that both his answers are correct? Right, I'm going to do this quite a long-winded way to explain what's going on, but then I'll show you the short, easy sum to do to get the same answer. So hopefully you know that the probability is the number of possible outcomes on the bottom of a fraction. So in one of these questions, there's 3 options. So the probability of getting one question right is a third, because there's one way of getting it right out of 3 possible options. The problem is we're not being asked that. We're being asked what the probability that he gets both questions right. So let's just try and visualize this. Let's suppose we've got options A, B, and C. So we've got A, 1A, 1B, and 1C. And to keep my example simple, I'm going to assume these 2 are wrong and option C is correct. Doesn't really matter which way around they are. We've also got 3 options for question 2. And again, we've got 1 that's correct and 2 that are wrong. Again, it could be any of these options. This doesn't make any difference. So what are the total number of possible outcomes and how many are correct? It would be tempting to say 2 out of 6, but I'm afraid that would be too easy. Because what we've got to think about is what guesses might Stefan make? He could guess 1A and 2A. He could guess 1A and 2B. He could guess 1A and 2C. Or he might have guessed 1B. If he guessed 1B, he could still have guessed 2A. He could have guessed 2B. And he could have guessed 2C. And finally, he might have guessed 1C. And he could still guess 2A, 2B, and 2C. This is what's sometimes referred to as a probability space. It's a list of all the possible outcomes. And if you're really stuck on a probability question and you don't know a shorter way of doing it, writing out all the possible outcomes is often a useful way to figure out what's going on. And you can see here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 possible outcomes. So what that tells me is the probability of him guessing anything where we're looking at both questions is going to be out of 9. What probability do I actually want? What is the probability that both his answers are correct? Okay, obviously it could have been any of these that were actually the right answers, but there's only one right answer to A and there's only one right answer to B. And in the way I've set it up, here he's got question 1 right. So we can ignore all of these options because he got question 1 wrong. But he needs to get question 2 right as well. So the only option here where he's got both right is this one. One possible option. So the probability is 1/9. That's a correct answer. You would probably get full marks for doing that, but you've got to do a lot of work to get there. So as promised, how do we do it the quick way? Well, whenever you've got a probability where you need 2 things to happen, where you need question 1 right and question 2 right, in probability an and is a multiply. So the probability of getting question 1 right is 1/3 and we want the probability of getting question 2 right as well, so we're going to multiply them together. Multiplying fractions, we just multiply the top and bottom numbers, so we get the answer of 1/9. And we can do that without writing out this big list. So if you understand that, this is by far the quickest method. So whenever you see that you've got the probability, you need the probability of one thing and another thing happening, work out the individual probabilities and multiply them together.